first a customer of Diamond early on, and then I was employed at Diamond in the customer service portion, and that was in the mid-'80s. And then we had an opportunity to come back and buy Diamond in 2000. Way back in 1968, Diamond was the leader in the Pro Stock stuff. They did a lot of the early Pro Stock engines, and then they moved on and they did a lot of NASCAR stuff after that. And after we purchased the company, we had an opportunity to work with Greg Anderson on his Pro Stock deal. So it was kind of like history repeating itself. Yeah, I learned early on when I was employed at Diamond, one of the things that I really appreciate about the founders of Diamond is they gave everybody the same support. At that time, we were doing a lot of NASCAR work, and if an average Saturday night racer called, he got the same product, support, and attention that the Richard Petty's and some of the well-known people got, and I really appreciated that. We've tried to instill that today. Well, I would think the future for Diamond is just to continue to do what we've been doing and listen to the customer, try to provide him with the products and the service that he needs. So I think the future of Diamond, hopefully, is it continues to repeat history.
Years of experience with standard design criteria that's tried and true. Okay. You know, that's really how we've done most of our design to date. Is the best thing we can do is get a starting point. You know, you give us a sample or some idea of exactly what you're doing, and more than likely we've done something like that or very similar before, and from there, that gives us our starting point. So I think that's the biggest thing. My name is John Kemp, and I'm engineering manager for Diamond Pistons. I've been here for 18 years. Most of our research and development process comes from iterative design revisions. That means that the customer generally sends us some information or a piston itself that they've started with. From that point, we can do some reverse engineering, gather what the skirt may look like, as well as other characteristics of the piston. So in testing and development, the customer may send us a sample. The customer may send us a chamber mold, piston, cylinder head, any one of these items we can reverse engineer and scan and or CMM inspect to derive the data needed for a custom piston design. So combustion chamber, we can scan that combustion chamber, create the offset. We can scan the valve locations, create those locations, all on custom cylinder head or custom piston requests that don't exist. So anything that we need to reverse engineer to derive whatever geometry we need, we can do that. From substructures, we only have so many forgings that can fit particular designs. So we do have the option and capability to create a billet design. When I say a billet design, that billet design can have this feature machined underneath as opposed to forged, or let's see, any type of custom feature that you wouldn't generally see on the undercrown of a standard forging. Those are the things that we can machine in, and that's our starting point of that substructure. From there, we can tweak where we actually put the support ribs, support struts. We can also perform finite element analysis to look and see how those loads affect the function of that component, and we can adjust properly. From there, it's up to the customer to test that and make us aware of any type of issues that they may see or any type of benefits in that change that they may see. And we can move through that design process on the next revision and continue to make improvements to that part. So they're going to test a combination of dyno and track, have a run component. They're going to send that run component back. We have inspection capabilities that allow us to put something on a CMM, laser scanner, and or form profile checker. We can check the flatness of a ring groove, we can check the cylindricity of a pin bore, we can check whether the skirts have started to collapse and started enhancing that secondary motion of the, and increasing the secondary motion of the piston as it's transitioning back up into the bore. We can also look at any type of scuff marks on the skirt. Those are also a good storyteller of what may be happening in the bore. Most customers don't have the proper instrumentation to be able to look at things at the OE level. One big one would be as easy as installing temp plugs on the undercrown of a piston, but that's a specific test, and a lot of these specific tests aren't necessarily paid for by a customer. So we rely on constant feedback from the customer to give that iterative design and revision improvement criteria. Now, one big improvement that we made years ago and we still continue to use to this day is center of gravity piston balancing. That allows us to locate the center of the balance of the piston to the center of the pin bore. That assists in that secondary motion in rock, especially on parts that have a large dome on one side and typically favor one side or the other in mass. As the piston speed increases, these types of changes also enhance the function of the piston. Another thing we're always trying to improve on is different surface treatments for the piston, whether it be our typical anodize or a ceramic coated crown or a moly coated skirt. This is going to lessen the friction of the part. This is going to protect the crown as a thermal barrier. The largest reason to anodize would be to prevent micro-welding of the top ring. The anodize protects as a heat barrier to the 2618 or 4032 aluminum and assists in removing that heat and removing the localized hot spots from areas. What sets Diamond apart from the competitors is that we create lots and lots of custom features. So no matter what you send us piston-wise, we will figure out a way to machine it. So from research and development standpoint, we can carry on with any research and development and iterative design process that's necessary, and we will strive to do that. We're not a company that you just order one thing from and that's all you get. For this part that I have in my hand, this is a full billet slug for a diesel. You can see it has many, many custom options on it. Some may have come from a run sample that the customer had given us, but we worked backwards to reverse engineer this, get this into the customer engine, and support him all the way through research and development, his own dyno testing, and into the vehicle. Whether it's a custom feature or support that you're in need of, Diamond Pistons is here to support you. We'll work from start to finish on your custom design and development project, and we'll be here every step of the way if you need us.
Our relationships with some of the higher end teams and the guys that are winning really help us because it allows us to develop a better product that helps understand, and it also showcases that the product's that good. We have guys out there going and setting records using our product. It allows the people that are trying to follow that suit to understand that that's the steps they need to take.
Jackson KTR here at Lights Out 11 at South Georgia Motorsports Park. We got the Shadow 2.0 on maximum kill. The components that it takes to keep this engine and this race car alive, running 215 miles an hour and going 354 on a street tire, are pretty substantial. We do a lot of abuse to the engine. This thing's pretty much detonating from the time I start it to the time I shut it off. If you guys watch the car run, you can see how much smoke's coming out of the trunk down there. We're almost burning it up every pass. I've ran Diamond Pistons and Trend Performance products for the last decade, and there's nothing else I trust to put in my engines to handle the kind of abuse that I put on them. And when you got Billy Stocklin putting a main jet in it, you just really never know what can happen.
What's up guys, Alex Laughlin here, winner of Lights Out 10, US Nationals, and I run Pro Stock, Pro Mod, and Radio vs. the World, and I run Diamond Pistons in literally every single car. We've made record runs and everything. There's no doubt that Diamond Pistons is the absolute best manufacturer in the industry, and I've seen these guys stuff. They've got a top-notch operation, and there's no doubt that these guys have the best products in the industry, and that's why we run them in everything.
Hi, my name is Mike Panetta. I am the Sales and Product Manager for Diamond Racing Products. Been with Diamond for 17 years, sales lead and product manager for over 12. Diamond's main focus is custom pistons. With our custom pistons, we are enriched with machining features, engineering, and other aspects of making a custom piston. Anything from a 2.750 bore to a 5.750 bore, in that range. We have forgings and the ability to make a full billet part. Some of the features that Diamond offers as a standard on a custom piston would be either a full round conventional style piston, forging, or an inboard slipper style or strutted, as many call it in the industry. Standard features include finished pin bores, ultra flat ring grooves, oil drain backs, forced pin oilers, and or internal milling for weight and unique crown shapes. Diamond's capabilities via our machining equipment and our engineering capabilities allows us to mimic any factory style DI dish, unique dome shape, dish shape, pocket location. A nice feature about Diamond's parts, comes standard, is our 3D milling on the crown. Our 3D milling allows us to machine radius all the sharp edges on the crown. That saves the engine builder from having to hand blend the part before installation. Diamond's custom piston program allows us to build any piston for your 4-stroke engine, anywhere from street, strip, to marine, to drag race, to circle track, diesel, vintage replacements, anything that you can come up with, we have either a forging or a billet design that will work for that application. One of the features that Diamond offers is our coating, our surface treatment. On any custom piston, we have a few options in coating. We offer a ceramic coating for the crown. The benefits there is a thermal barrier protection that allows to reflect the heat back into the chamber and not through into the top ring and the ring grooves. Diamond also offers a moly skirt coating. We do this in 2 different applications, a spray-on coating and then a screen print version. This is done mostly on our shelf stock, where a sprayed-on coating can be applied to any custom part. We get into our anodized offerings. We offer 3 different options there. Our Type 3 anodize, which is seen here as a green coating, we anodize as a complete part. The benefits here are micro welding of the ring groove protection, thermal protection of the crown, and also expansion protection. With the anodize, it's an impregnation process. The anodize actually soaks into the surface around a thou and then also builds up on the outside of the surface around a thou. So it gives you a 2 thou protection before you get to any raw aluminum. Our third type of anodize is what we call our PTFE coating. It's a Type 3 anodize that's actually sealed with a PTFE Teflon. The reason why we do that is the PTFE actually fills the pores in the surface of the anodize, which allows it to have a smoother, softer surface to wear on under operation. This type of coating we usually use in a street application or methanol or alcohol applications. Diamond Piston's ordering process for customs is fairly simple. We require a custom piston form filled out. Either that can be supplied to you by your tech salesperson or can be filled out directly from our website. This form features all the critical dimensions needed to build a part based off of your engine measurements. Bore size, stroke, rod length, block deck height, cylinder head information, application, and what features you would like the part to have. Once the form is submitted, our helpful sales and tech staff work with you to finalize the process of the build. They will give you their recommendations of what features your application should use on the piston. Here at Diamond, our sales staff is built of racers and engine builders. You can reach one of Diamond's sales reps for any of your custom piston needs, either at 586-792-6620, or you can reach us from our website at www.diamondracing.net.
Diamond supplied our LS Competition Series piston kits for this build. The Competition Series kits feature 3D crown milling, ultra flat ring gears, precision honed pin board, and a molly skirt clip. Included as a standard package, these kits include gas nitrided ring sets featuring a Napier second ring and a standard tension oil ring, along with a Trend Performance 4130-185 wall bit. Diamond's Competition Series offers over 100 different part numbers for the LS and LC engine families.
Welcome back. Lake Speed Jr. here, along with Jimmy Barton and David Lewis from Roush-Yates Racing. If you were hanging around all day, you saw us talking this morning about blocks. Well, now, thanks to the guys at Diamond, they've set us up. We're going to talk a little bit about pistons, wrist pins, coatings, clearances, all those little things about, you guys know I love the ring seal soup. So making that piston happy. So let's talk about that a little bit. And first thing, let's really talk about piston materials, and you guys are the pro engine builders, so give me a little bit of an idea. Everybody knows that 2618, 4032, hyper-eutectic, there's lots of different piston materials, but typically most race pistons are going to be 2618. So why is that?
Well, because it's a more durable material. It's probably the strongest of the materials. It's noisy in a street car, that's why they use the 4032.
That's based on thermal expansion.
Based on thermal expansion. These don't expand as quick. They do get quiet, but they run looser clearance than the 4032s also.
Right.
Because they grow more than the 4032s.
Right, that's why you have to have more clearance to begin with cold, which is why you get the more noise, because you're getting more slapping around.
And yes, the 4032 is more I won't say it's a street piston because it's really an upgrade from a cast or a hyper-eutectic piston, but in the classic car world or whatever, you'd want a 4032 if you're worried about the noise the motor's going to make while it's cold, or if you've got a quiet exhaust system on it where you can hear the pistons.
Mm-hmm.
So, I mean, the 2618s with above 6,000 clearance on them, they rattle when they're cold.
Right.
I mean, they're going to.
Yeah, it's going to happen.
And your knock sensors in your late model cars, if you put them in there, pick them up. So
interesting.
So the 4032,
makes sense.
Well, it's the same thing he was talking about on the balance earlier.
Exactly.
The sensors in the car, they balance stuff better because of the noise.
Mm-hmm.
Well, you got to have the tighter clearance piston to do away with the noise in your computer cars.
Exactly.
So.
I know from doing some testing with Ben Strader, who was on one of the videos earlier, on direct injection engines like an LT1, LT4, LT5, being a DI engine, those engines do have some low speed pre-ignition, some detonation stuff, and that knock sensor, you don't want to give it a false positive because of what Randy said. It's going to do all these other things to try to protect itself, which really isn't what you want an engine doing anyway.
No, I mean, it can fatten the fuel system up, it can knock timing out of it, and if you're at a red light and you need to go, you want timing.
Right, exactly, yeah. Especially if it's who's parked next to you, right?
Well,
we didn't say that. No, that's all good. So beyond the piston material, we're looking at this one, and this is what we would consider a reverse dish style. So obviously through the NASCAR days, I can remember back in the old days where you had the old domed pistons to try to get the compression, and you work that way. Well, things have kind of changed. So, I mean, you've been around all this from many eras of evolution. So give me your perspective on that dome versus the reverse dish versus a flat top.
Well, back in the 70s when you had the cast iron heads and you were using production heads, the chambers were big in them.
Right.
So in order to make compression, you put a dome on the piston. Well, now, late in these years, everybody's making cylinder heads. They can make the chamber smaller.
Right.
But when you make the chamber flatter and the valve angle flatter, you don't need the dome piston anymore. Plus the dome piston, if you remember, the small block Chevrolets run real good with 40, 42 degrees of timing in them. Nowadays, you rarely see over 30.
Right.
I mean, it's all chamber design and piston design.
And the big reason for that excessive, or say excessive, we call it excessive now, but that higher level of timing is because that flame path had to go so much further because you got this mountain in the way.
It's strictly flame provocation. I mean, if you remember back in the big block days, people would grind a slot in them where the spark plug had a flame notch.
Right.
And it was to get the flame to travel better. Well, the purpose of the smaller chamber in the dish is to get the spark plug to the center of the mass. This makes up the bottom of the chamber. That's why it's called a reverse dome.
Right.
You have the same, well, approximately the same thing in the piston as you have in the chamber.
Exactly.
And you want to put the spark plug close to the center of that chamber. That's why the Hemi works so well, is because the spark plug's in between the valves in the center of the chamber. And you know, the Hemi also had a dome piston, but
Exactly.
you know, and the Hemi leans itself to a power adder too.
Oh yeah, there's a lot of good things there. I mean, my dad, you know, still does the vintage go-kart stuff, same area as from your dad, David, and those are all two-strokes, are all domed pistons as well, and domed cylinder heads. So I mean, there's obviously something about that having that flame path, because the whole goal to make power is to burn all the fuel so you can combust the air and make heat, because that's what expands the air and causes the piston to make work.
I mean, I would rather have flame travel than compression. I mean, perfect example, years ago, 706 drag motor, big compression, wouldn't run. I took the motor from a man when I was in Birmingham and cut the dome off his piston. Well, he had a fit because I cut his compression down from really high down to like 11.5, 12 to 1. Well, the motor run better without the compression. It didn't take as much time in, but he had a fit. He thought he had to have compression to make all that horsepower, which, you know, once they got the chambers on the heads better and you could put a dish in the piston or a flat top or even a shorter, rounder dome that didn't have a lot of peaks in it, it makes all the difference in the world of the dome shape of the piston.
Yeah, again, about is it flame travel. We want to burn the fuel. If the flame can't travel, it can't burn that gas mixture over here, which is going to generate work.
Just like the Diamond video before us said. You know, they were making clay molds or sending parts in to make the piston off of. They were scanning the chamber so the piston would fit the chamber, because they didn't want all them sharp edges and all.
Right.
So, yeah, I mean, it's all related to flame travel.
So, moving on from piston design for those reasons, one of the other things here, and of course the Diamond guys have their logo nicely in there, is skirt coatings. Obviously, you know, the skirt of the piston is riding on a film of oil. It's not going to be contacting the bore, we hope, under any circumstance. So that skirt design is also really important. So why don't you elaborate a little bit about, I mean, you guys have lots of different experience and different motors and different piston designs.
Well, the cams on the skirts are different based on what clearances you want. And also, just like talking with the honing procedure, how much oil is held in the hone. Primarily, in my opinion, and it's strictly my opinion, the skirt coatings are for cold crank up.
Yes.
And what does David think about it?
I would agree. We've seen the same thing, and it all has to do with the cam of the piston and the stiffness of the cylinder wall versus the cam on the piston itself.
Right.
You know.
In my analogy, I would say about the cam of the piston and that skirt profile is no different than a water ski. You know, because it's that hydrodynamic lubrication is what we call what the piston's being lubricated by. There's, you know, I'm being the oil geek here for a minute. So really, if you think about lubrication, there's 3 different stages of lubrication. You've got boundary film, which is that metal on metal. That's your flat tappet cam, which is why the whole ZDP thing for 15, 20 years has been a topic of conversation, which I think there's going to be a video tomorrow to talk about that a little bit. But that metal on metal contact, that's boundary lubrication, and that's where the additives in the oil do all the work. The next thing is going to be that, they call it mixed film. That's that piston rings or near ring reversal are going to be somewhat boundary, but also somewhat on the oil film. That full film oil film, that is what we call hydrodynamic. And the best analogy is, if you think about water skiing, if the boat's not moving, where are you? You're down in the water. But as the boat begins to move and gain speed, the skier comes up out of the water. But anybody that's been around water skiing a lot, and boats a lot knows that, you know, a slalom ski, the boat's got to go a lot faster to get the slalom skier up. But a wakeboard pops right up. So that's back to that piston skirt design you're talking about. That lubrication property, with everything else being the same, that skirt design is that narrow ski or that wakeboard design, if you will, to try to cause that lubrication property to begin to happen.
And there, the cam is to deal with the thermal properties of the cylinder growing and the piston growing.
So it's going to
And
open out.
how much rock it's got in it. And that's all related to different engines and different cooling packages and all that. And also, it's just, the piston's just like a bearing. You want the ring to touch the cylinder wall and the skirts not to.
Exactly.
You want the skirts to ride on oil, the rings to touch the cylinder wall.
Yeah, that's a perfect way to seal up. One last thing before we close this segment and move to the Q&A segment of this, wrist pins. So obviously, to me, again, just my opinion, this is the backbone of the piston. I know some guys have different theories on how wide it should be, what wall thickness it should be, taper. You've been to Bonneville and gone, well, 277 miles an hour backwards, but well, that's a story for another day. As a Bonneville guy and building lots of different engines, let me know a little bit about what your thoughts are on that.
The deal on the wrist pins, the standard wrist pin used to be 2/900, 927. Okay, everybody's down to 2 inch 750, and the deal is you take a pencil and grab it out at the ends, you can bend it and break it.
Right.
If you give it a little thicker wall like this pin and shorten it up to 2 inches, or break that pencil in half and try to break it again, it just don't flex as much.
Right.
And now they moved the pin bores inbound on the piston so that it's got the same area in the wrist pin area.
Yeah, the pin boss is the same
The
area.
pin bosses is the same area as it was on the 2950 pin. So you don't have the moment of deflection in it in the shorter pin that you did in the longer pin.
Fantastic. So I think we've now reached the Q&A section of this, so I will try my best to operate this device. Perfect. Here we go. Now let's see if we've got any questions here. Okay. Are they able to take some clearance? Okay. Can you take away some of that extra running clearance that you need for a 2618 by using a coating? I know I've never personally used it, but the line-to-line coating is an abradable skirt coating. Have you guys ever come across or used any of the line-to-line coating?
I've never used it myself.
Okay.
I know some people that have used it in superchargers.
Right.
That let the rotors make their own clearance and fit. I think it would work on this application. Where it would stop, we hadn't done it, we don't know.
Exactly. I mean, I think it's a good idea, good thought process.
Definitely, good
You
idea.
know, yeah, but make sure you see. That's a good. Who that was Kenny. Thanks, Kenny. Good thought. Good question.
Definitely.
Oh, here we go. Dima Elgin. You guys know who Dima Elgin is, right?
I know of it.
Yeah. Okay. So Dima is watching. Hey, Dima. Good to see you. Thanks for the question. He said, remember that with higher compression, you have more pumping loss as well. Plus, with the dome, you have more surface area, which can also not be so good. So,
I mean, and a dome piston is not necessarily a balanced piston unless it's a hollow dome piston. If it's a solid dome piston, you're going to have one side of it's heavier than the other.
now you're going to get more piston rock,
And
the more the one piston wants to rock, and now you're unseating the rings, and you're defeating the whole purpose of everything.
That was the whole purpose for making the hollow dome piston, trying to balance it.
Got it.
So,
Okay.
I think the water skier is going to fall over.
yeah, exactly. Yeah, the ski's got too narrow on us out.
Yep.
So here's a good question from Joe. Any difference between a press pin or a floating pin?
there's schools of thought on that. The press pin is basically for production automobile stuff. You heat the rod and put it on. Nowadays, used to you press them together and they skin them going through the pin bore. You got 2 rotating parts in the piston versus 3 when you got a floating pin.
Right.
I mean, you make the piston, usually we put a smaller amount of clearance in it than the rod, because the rod being steel tends to tighten up on the pin, and the piston being aluminum tends to loosen up on the pin. clearance is based off diameter of the pin.
Right. Back to that same bearing area. You got to have enough bearing area. You got to have oil getting there.
And if you put your race motor together and you just put the pistons on with a press fit pin, and then all of a sudden decide that you ain't got enough piston to valve, or you change the cylinder head that's got a higher valve seat in it or something, you tear the piston up pressing it back off to cut valve release in it, which you don't want to do that after it's machined anyway. But say you unforeseen and had to, or
stuff happens.
or you put a head with a moved valve train in it that don't fit the pocket, you got to move the pocket. So the floating pin is just a better option for me.
I agree. So we have a couple more questions. Pin button versus oil support ring when the pin intersects the oil ring channel. I mean, the pin button stuff, I've only really seen that on like real big cubic inch power adder.
My blower motor has them in it.
Okay.
The pin button is much better for the support rail than the rail itself. Now, you're the ring guy.
Well, yeah, I mean, that's the whole thing, is that obviously when you have side relief piston, and you've got, in this case, a perfect example, the oil ring is intersected by the pin. Yeah, you can put that rail in there and hold it, but the more cylinder pressure, the more boost that wants to flex, because none of this is static.
So if you've got a pin that goes in there and that covers the whole thing, that the rail holds the button in, I think that's a better option.
Oh, it's structurally way better. More support, so that now the ring can't move as much, and I would think it would probably even impart some strength to the piston, because again, you're saying this is the structural part.
Right.
This is the backbone.
And if you're using the pin buttons, you traditionally don't put locks in it, so you don't have to cut the groove in.
Another nice thing to do, because we all hate putting in circlips.
But
no one likes that, by the way. There's no one on the planet that says they like that. If they do, they're masochistic or they're lying, one of the two, right?
I don't know. His father made us a unique fixture for putting in the wire locks, and it works really well. Now, getting them out's a different story.
It's like a snipe hunt around the shop.
Yeah, but as far as that,
circlips versus wire locks. That way, spiral locks. Yeah, same kind of thing.
Spiral locks are fine. The true arcs are kind of outdated. They work, but the wire locks are traditionally, I think, the best thing going right now, because the clearance is a little tighter on the end of the pin as far as end load. I mean, you can make the spiral lock 0 if you want to, but generally on the wire locks, in my experience, they've been between 12 and 15, but they have a taper on the pin to where if the piston should touch the head or something, that'll knock a spiral lock and a true arc out.
Right.
On a wire lock, it'll eventually knock it out, but it'll take the side off the piston before it does.
You just want to make sure you seat the wire lock when you put them in.
Right.
They're a little more sensitive than a regular spiral.
So that brings me to another question, and I got a couple more here we want to try to get to. We only have a couple more minutes left in this segment, but talking about the pin coming out, or the lock coming out, yeah, I've heard stories, and never experienced myself, but in some big cubic inch engines, really big pistons with pretty big pins, that there can be enough deflection in the pin boss that the wire lock can actually come out itself. Actually, maybe it's more at really high RPMs too, because all that big part means it's a pretty big clip with a lot of mass, and at really high RPM, it can actually unseat itself.
I personally hadn't seen a wire lock come out unless it took the outside edge of the piston off.
Okay.
Or the groove was cut in. Because when that pin with the taper, when it drives against that lock, it's driving it into the piston.
Got it. So one of the questions I want to answer here, John Kazi, thanks for the question. These are the pistons that Diamond sent, so I don't really know all the details of this piston design or what it is, so that would be a question I would defer to the guys at Diamond and let them answer why that shape is the shape that it is, because it's literally just the piston that we have for the thing, because I'm just the dummy talking head at this point, so we'll just call it what it is.
And I'm definitely not a piston guy.
Yeah, John, you know more than I do, and him, so there you go. Okay, here we go. DLC versus bare wrist pins. As a lubrication guy, I'm all about a DLC coated pin.
All right, here you go. Back in the day, 70s again.
Yep.
You could take stock rod, hone it, take one of your Thompson TRW pistons that had a gas hardened pin.
Yep.
It's really hard. You could run it on that rod, steel on steel, and it was fine. You put that pin, a racing pin, the softer pins, but stronger in it, it will gall because they're two similar metals.
Right.
All right, the DLC is so hard, you can put it in anything, it ain't gonna gall.
Yep.
But if it flakes off in your motor, it will destroy everything.
Oh yeah, that's the double-edged sword of DLC. Is that DLC is wonderful as long as it stays on the part. If it delaminates,
it has to be prepped properly and put on properly.
Yes, sir.
If it comes off in the motor, you might as well pour glass beads in it.
Oh, it's probably worse than glass beads through your motor. So, but it's one of those things where it's a application dictates what the parts you need. That's been the message all day, that application dictates both the chemistry, or in this case, the coatings, and then we can go there. So now we finished this. Thank you guys for your time. We really appreciate it. Let's go to the next tech chip.
We're here at Straub Technologies Day with Jeff Havens from Silver Seal, and we're going to talk about some of the product offerings that Silver Seal and Straub Technologies offer the industry on the LS-based engines. Jeff, can you tell us how your family's background and how you all, as far as with your connections up in Detroit and stuff, got into this?
We started out, my grandfather started out in the late 50s in Detroit as a jobbing machine shop. Back then they carried everything from paints to nuts to bolts, and in the back room they do a lot of cylinder head work. And he patented, developed, and designed the valve spring insert, which has now become a staple in the automotive aftermarket as far as cylinder head rebuilding goes. And with that connection, obviously we got a lot of interest from the OEs over time, and you know, over the years we've supplied OEs not every year, but almost every year, either for parts and service, performance, our valve spring inserts, which has really opened up a lot of doors to us in the Detroit area with sourcing product for the automotive aftermarket.
So with you being the third generation, you can say you all got decades of contacts in the Detroit, Michigan, Ohio area.
Absolutely, yes.
Okay. Well, tell us a little bit about the LS market and some of the products that you're able to source and provide to the aftermarket performance world.
As you all know, the LS market has went crazy in the last few years. So we've went to a lot of our customers out in the field and asked, what are you guys looking for? What do you need? And you know, a lot of these bolts are specific to General Motors. So we went out and sourced all the hard to find stuff that you'd have to go to the dealer and source.
And with the LS platform, since it's a torque to yield style bolt, unlike the old small block and big block Chevrolet, you have to replace every bolt in the LS market with anything that you disassemble of this thing, correct?
Yep, GM did a thing where just about every single bolt on an LS engine is a torque to yield bolt, even down to some of the timing cover bolts and even some of the coil bolts, believe it or not.
Now, I think you had told me a story once about a large PER that was actually trying to reuse some of the product and some issues that they were having, right?
Yeah, we had a lot of fun with that one because these oil galley plugs, GM had engineered a special crush washer on the inside of it. And what was happening is when the PER was running these in their hot tank, the actual crush washer, which you can barely see on the inside of the plug, was falling out.
So even with the camshaft change with an LS motor, you've got to remove the cylinder heads. So that means you've got to replace the head bolts and stuff. And currently I know we sell thousands of head bolts every year.
Oh, yes.
And so it's not just thousands of camshafts and stuff being sold. You have to replace all those bolts. And Silver Seal, Straub Technologies, we are the source for that kind of stuff. And we're going to go through some of the stuff that we've got and some of the unique product that we can that you all can get from the companies and source through us for your LS projects. Jeff, let's take this coil for example. This is a GM coil, but it's a very special GM coil, correct?
That's correct. It's a 140,000 megajoule coil, and it's the highest output coil for the LS in the marketplace today.
Okay, all right. What about this lifter guide? What can you tell us about this lifter guide?
This is an OEM GM lifter guide, and you can tell by the part number stamped in it. There's a lot of lifter guides out there in the market. You can go on eBay today and find lifter guides, okay? The problem is those are knockoffs, okay? And you're gonna have problems with those, and we've already had the GM engineers test those. You will find that the plastics they use, they get soft and they do not have the supports on the inside of the lifter guide to take the abuse the LS gives to it.
And the other thing too is it has the OEM Delphi part number right in the center, so you know if you're getting an actual GM part. And you can see here easily it's got the GM Delphi part on the plastic piece. These little gaskets seem to burn out quite a bit here on the off steam vent.
Absolutely, yep. That's something everyone forgets about when they go back to put their motor together. They're like, where'd we put those?
And this little dog bone, we sell a few thousand of those a year, don't we?
Absolutely. Another great hard to find product that you need for the LS.
And I know at about 100,000 miles, this plastic gets fairly brittle and stuff, and this thing goes bad and can cause some oil pressure issues. So when you're pulling your LS apart, you better sure to back the pipe plug off the back side of the block and pull out what we refer to as the dog bone. And I think we see, as far as the cam plate for the LS, a lot of those go out the door also.
Absolutely. The problem you find with a lot of the plates out there in the marketplace now is they're not hard enough, and they will start wearing a groove right in the back of this cam plate. So if you don't know where your product's coming from, you will run into problems, and that's why we went with the best in the marketplace.
Now, one thing that we do at Straub Technologies, and available either from Silver Seal or Straub Technologies, this was a little deal that Roush-Yates Racing came up with on the LS spec engine that they do for NASCAR. And what we do is we will ball mill grooves at clock positions of 12, 3, 6, and 9. And what this does, it stores oil there and keeps the wear down. These are available in a modified OEM plate with that oil groove. And today I hear that you can actually pull an LT motor apart, and GM has already done this. So they've learned their lesson, and now they're actually machining these plates at the factory and putting them in the LT motors. About head bolts and stuff. So we touched on that, being it's a little bit torque to yield, but talk about the GM bolt quality compared to a lot of the stuff that's the knockoff Chinese stuff that's coming in.
Yeah, GM's quality is second to none right now. There is a lot of head bolts out there in the marketplace. These are actually OE head bolts. GM's went with a torque to yield bolt because it is the best. It's going to give you the best quality fasten, I guess I should say.
Yeah, I agree with you, yes.
Because GM figured out with torque to yield bolts, you need half the size bolt than a Ford or a GM with twice the strength. You'd have to torque a Ford bolt to twice the foot-pounds as a GM bolt because they're non-torque to yield.
Okay. All right. Now, it's kind of interesting what you've done here with these swap kits, as you call them, that have got most of the fasters that you would need for a camshaft swap. And being that the LS platform, the most popular modification to an LS is a cam swap. So can you tell us a little bit about the cam swap kit, Jeff?
We developed this cam swap kit to do 3 engines. And again, per customer's request. I would love one of these kits. You know, I need something to organize my bolts, so when I need something, I'm not running down to the dealership and grabbing it. So we came up with this kit with the help of Chris, with everything you need to do 3 LS engines.
So I see here you've actually got the OE part number, and you've actually got the foot-pounds and torque that you'll need.
Yeah, we put all the torque specifications you need on there, so if you, instead of going to the book, you can go right to the chart here, and it shows you everything you need on there.
So you've got another kit here, which you just call the general hardware. So this is just a lot of just little knick-knack type stuff.
It's the stuff you forget about, stuff you need. We've got some of the camshaft sensors in here. We throw some of the steam pipe gaskets in there, connecting rod bolts, valve seals, water pump gaskets. You know, how many times do you guys replace these? All the time. Timing cover seals, keepers.
And one thing with the GM, at the temperature that it runs, it runs in extremely hot. It's almost at boiling. So a lot of these gaskets after 100,000, 150,000 miles, when they're picking these things up in the junkyard, this stuff needs to be replaced. All of this can be found on Silver Seal's website or Straub Technologies' website. And speaking of gaskets, we keep the OEM gaskets that GM supplies on the motors and stuff. So these are in stock, and these are actually OEM part numbers that GM uses on the builds. We also keep the intake gaskets, the valve cover gaskets, the valley cover gaskets, the oil pan gaskets, and front timing cover and rear main cover type gaskets. Again, all of these are available at Silver Seal. I've got a little thing here I'd like talking about the off-gassing. So again, back to Roush-Yates Racing. These guys have developed this spec engine for NASCAR, and one thing that they found was the amount of heat that the engines build up, that they would actually go into a thermal detonation. Well, when the LS was derived, one thing it had to meet was fuel economy and emissions. And one way that you solve emissions is that you keep a lot of heat in the combustion chamber for the catalytic converter to burn stuff up properly. So they limited the cooling around the combustion chambers. What Robert Yates figured out, with a slight modification to the head gasket with extra cooling holes and an off-gassing kit, and off-gassing in all four corners of the engine, it actually increased the RPM and gave better performance for the engine and had a lot less thermal issues with the engine overheating and stuff over time. So here's a NASCAR team that has modified the LS, and now you get to buy the product that they're using to give these engines maximum performance in the high performance industry.
Hey Chris, why don't you tell me some of the cool things you did to the rocker?
Well, with your all sourcing capability, what we did was we took the body of the OEM rocker and we have that rim finished. So that takes all the little imperfections and any surface area imperfections. It also polishes up the sled very nicely for the rocker. And then what we do is the bronze trunnion kit that we do for the OEM rockers, we go ahead and install that trunnion with our bronze bushing kit and trunnion, and then this is sold with the bolts and hardware as a complete kit. So we offer this as a lifetime guarantee when you're running our camshafts, and this rocker is good like any other OEM rocker to 640 lift. So these are available from Silver Seal or Straub Technologies, and if you need them, give us a shout. Tell us a little bit about covers and stuff, Jeff.
We got a full line of rear and front timing chain covers for the LS. You can get them loaded, unloaded, with sensor, without sensor. We've got the gears, chains.
The chain deal, that's one thing, because you've got the OEM gear, and I think the OEM chain is pretty good. But what happens is a lot of times people will want to use the OEM cam gear and the OEM crank sprocket gear, and what they'll want to do is use an Iowa's chain. So this is a single roller chain sold by many other companies and stuff. We stock this, and this chain made in Germany is the highest quality. So this chain we know runs in engines 7,500, 8,000 RPM on the stock cam gear and on the stock crank gear. What about valve springs?
For years, you've seen the blue spring out there, which GM has produced. GM's discontinued production of the blue spring as of a few months back.
And that spring was actually used in two venues. They used it on the circle track crate motors, the 602s and the 604s.
That's correct.
And it is the only accepted valve spring on those two forms of circle track racing.
That's correct.
And this was really the go-to valve spring for the LS market because they called it the LS6 spring.
Absolutely. If you see springs out there today, they're not real GM springs if somebody's selling a new blue spring, because they're gone. GM went to which we call the metallic or gold spring. It's really not gold, but they had a problem with them breaking, okay? And GM engineers realized that. And it's hard to tell here, and we'll do a close-up on that, but the actual grind on the springs are just a little bit different. Basically the same as the blue spring, but they've changed the grind on it because you were getting breakage on some of these blue springs over time.
And you said it's a gold spring, but I see it's got some white markings on it.
That's the white OEM marks.
So that designates that it is actually a GM spring.
Absolutely.
And then I guess we need to talk about the elephant in the room, Delphi lifters.
We're getting there. I think the whole country's knows about that one right now.
Yes. But we hope that the supply chain will be getting filled up here. But you've been shipping a lot. You've shipped a lot of Delphi lifters over the years.
Absolutely, tons.
And issue-wise with those,
I haven't had a labor claim.
And I don't think David Lewis down at Robert Yates will mind me saying this. That same lifter is what they run in the NASCAR spec motor. It is the approved lifter for NASCAR spec motor, is the Delphi lifter. Well, I think we've pretty much covered everything today. I mean, I appreciate your time coming down to Straub Technologies.
Appreciate you having us down here. Yeah, absolutely.
All right. We appreciate your time today. Thank you.
Thank you very much. Take care.
What a day, what a day, what a day. Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.